am Dr.Bindhu T, Assistant Professor, Department of Science and Humanity, Emmanuel Arasar, JJ College of Engineering, Nattalam. My topic, matrices. Let A equal to Aij. Aij is a general form of matrix. Then entry values A11, first row, first column element, A12, first row, second column element, then etc. A1n, first row, nth column element. Then next row, second row element, A21, second row, first column element, then etc. A2n, then etc. Last mth column, mth row element, AM1, AM2, AM3, etc. ANM. This matrix order is m by n. M by n means m rows and n columns. This matrix belongs to m by n. M by n is a order value. Then this size value is called m by n. I will explain the operations of matrices, sum and scalar products, to matrix multiplication. The next one is properties of matrix operations and the inverse of a matrix and elementary matrices. Then operations with matrices. Then let A is a general form of a matrix. Then Aij is a ijth entry. This matrix, all the elements are called entry elements. Then ith row vector Ri equal to Ai1, Ai2, then etc. Ain. This matrix is called a row matrix. Then only one row is given there. Then jth column vector Cj equal to C1j, C2j, etc. Cmj. Then only one column is given there. This matrix is called the column matrix. Next one is square matrix, that is m equal to n. M is a number of rows, n is a number of columns. Number of rows and number of columns are equals. Then this matrix is called the square matrix. Diagonal matrix. Let A equal to diagonal d1, d2, etc. dn. These elements write the matrix in diagonal form. Then d1, h0, etc. 0. Then 0, d2, etc. 0. Then diagonal elements is d1, d2, 0, etc. dn. Then d1, d2, etc. dn are called the diagonal elements of matrix A. The next one is trace. A equal to Aij, the general form of matrix. This matrix is order n by n. Then trace A equal to A11 plus A22 plus etc. plus ANN. This sum of the diagonal elements. Trace A. Then A matrix is given there. Trace A means sum of the diagonal elements. Then for an example, A equal to matrix of 1, 2, 3, 4, 5, 6. That is equal to this matrix. Consider R1, R2. Then R1 is a first row element 1, 2, 3. R2 is a second row element 4, 5, 8, 6. This matrix is called the row matrix. Next, A equal to, then same matrix, that is consider C1, C2, C3. C1 is first column element 1, 4, C2, then second column matrix 2, 5, C3, 3, 6, third column matrix. This example is called the column matrix. Let A equal to Aij. This matrix order m by n. Other one matrix B equal to Bij. Then matrix order is m by n. These two matrices are equal. A equal to B if and only if Aij equal to Bij. These two matrices, all the entry values are equals. Aij equal to Bij. Then first one is A11 equal to B11. A12 equal to B12. That is, then etc. A1n equal to B1n. Then last element Amn equal to Bmn. This all the entries elements are equals are in these two matrices. Then example, equal matrix. Then A matrix is matrix of 1, 2, 3, 4. B matrix is A, B, C, D. These two matrices are equals. A equal to B is given there. Then the entry values are equals. Then first entry value, then 1 equal to B matrix first entry value A. Then that is A equal to 1. Next second A matrix second element is 2. Then B matrix first row second column element is B. Then B equal to 2, then next value C equal to 3 and D equal to 4. Then two matrices are equals, then all the entry values are equal are two matrices. Definition: the sum of two same sized matrices is their entry by entry sum. The scalar multiple of a matrix is the result of entry by entry scalar multiplication. Then first one is matrix addition. Then A and B are two matrices are given. Aij matrix is capital A, Bij matrix is capital B. Then adding the two matrices A plus B equal to, then matrix Aij plus matrix Bij equal to matrix of Aij plus Bij. Then order is m by n. Then matrix addition means same order matrices are adding there to different types of order matrices, that is not applicable for addition matrix. Scalar multiplication: if A equal to Aij m by n, C is a scalar element, then C into A equal to matrix of C into Aij, then order m by n. C is multiplied by in all the entries of A matrix. Matrix subtraction: A minus B equal to A plus minus 1 into B. Then A and B are matrix value. Then subtract the two matrices. Then substitute the form A plus minus 1 into B. Then minus 1 is multiplied in all the entries in matrix B. Next adding the two matrices. These two matrices is same order but different order. It is not applicable for matrix subtraction. Then example, matrix addition. Then two matrices, first matrix minus 1 2 0 1 plus second matrix 1 3 minus 1 2. Two matrices order is 2 by 2, 2 rows 2 columns. Then same order is given there. Then adding the two matrices minus 1 plus 1. Then second first row second column element, then second matrix first row second column elements 2 plus 3. Then next one 0 minus 1, then 1 plus 2, then 0 5 minus 1 3. Next adding two column elements, then 1 minus 3 minus 2 plus minus 1 3 2 equal to 1 minus 1 minus 3 plus 3 minus 2 plus 2. All the entry values are 0. This is a column matrix. Next, matrix multiplication. The matrix multiplicative product of the M by R matrix G and the R by N matrix H is the M by N matrix P, where Pi comma j equal to Gi comma 1 H1 comma j plus Gi comma 2 H2 comma j plus etc. Gi comma r hr comma j. I is a row element, R is a column element. Then G matrix, M is a row element, R is a column element. Then H matrix, R is a row element, N is a column element. Then product matrix is P. Then P row element, number of row is M, number of column is N. that is GH equal to this general form is GI comma 1, GI comma 2, GI comma R. Then the product means first row element into first column element in other matrix. The I comma j entry of the matrix product is the dot product of the row I of the left matrix with column j of the right one. Matrix multiplication, then some matrix, first one matrix A11, A12, etc., A19, etc., AN1, AN2, etc., AMN. Other one matrix B11, etc., B1n, and this B21, etc., B2n, then etc., BN1, etc., BMN. This multiplied the first row into first column element. This is a first entry element. Then second, first row second column element is first row is multiplied by second column element. Next entry element first row into third column element. Next first row into the fourth column element, then etc. First row into last column element. This is a first row element. Then same procedure is substitute this in these two matrices. Then final answer is find out. Then notes: A plus B equal to B plus A. Adding two matrices, then next change the matrices, then adding that the given the same answer. Then multiplication is not applicable, then AB is not equal to BA. Matrix form of a system of linear equations. Then first m linear equations are right there. A11 x1 plus A12 x2 plus etc. A19 xn equal to B1. Second equation A21 x1 plus A22 x2 plus etc. plus A2n xn equal to B2, then etc. AM1 x1 plus AM2 x2 plus etc. AMN xn equal to BM. These equations are called the M linear equations. These equations write the matrix form. Then first matrix A11, then x1, x2, etc., xn are variables. These coefficients are writing the matrix form A11, then x2, A12, then etc., xn variable coefficient A1n. Then first linear equation is formed by the first row element. Then second linear equations coefficients are write the second row elements, then etc. Last linear equations coefficient variable coefficients are write the last row elements into, then writing the variables x1, x2, etc., xn equal to, then linear equation right hand side values b1, b2, etc., bm. These equations is of the form Ax equal to b. This equation is called the single matrix equations. Partial matrices. A equal to matrix of A11, A12, A13, A14. Then second row element A21, A22, A23, A24. And third row element A31, A32, A33, A34. This is order is 3 by 4 matrix. In this matrices splitted into 2 by 2 matrices. Then first and second row 3 entry values is formed by A11 matrix. Remaining A14, A24 is A12 matrix. Then third row element A31, A32, A33 is A21 matrix, A34 is A22 matrix. So 3 by 4 order matrix is converted to 2 by 2 matrix. Then next matrix A equal to, then same entry values are given there. Then we have to write that R1, R2, R3. R1 is a first row element, R2 is a second row element, then R3 is a third row element. This is a column matrix. Next matrix, same entries are given there. This matrix, this is converted to C1, C2, C3, C4. C1 is a first column element, C2 second column element, C3 third column, C4 is a fourth column. Linear combination of the column vectors of matrix A. Then A matrix A11, A12, etc. A1n. Then second row A21, A22, etc. A2n, then etc. AM1, AM2, etc. AMn. This matrix's order is m by n. This matrix is considered matrix of C1, C2, etc. Cn. The A matrix is converted to column matrix. The C1 is a first column matrix, C2 is a second column matrix, then etc. Cn is a third column matrix. Then X value is X1, X2, etc. Xn. Then n variables are given there. Then next find the value of Ax. Ax equal to, then A value is A11, A12 is A1n, then etc. Then m by n order matrix, X is A, X1, X2, etc. Xn. These two matrices are multiplying there. Then the answer is A11 X1 plus A12 X2 plus etc. A1n Xn. Then second row element A21 X1 plus A22 X2 plus etc. A2n Xn, then etc. Last element AM1 X1 plus AM2 X2 plus etc. AMn Xn. This matrix order is m rows and 1 columns. This matrix is converted to column matrix form, that is equal to, then X1 first element, first column, first element is a same element, same variable element. X1 is a common variable, then take the outside X1, then matrix of, write the variable X1 variable coefficient values of inside the matrix A11, A21, etc. AM1 plus next first column second element H2 variable is a common, then take the outside, write the coefficient value in inside the matrix A21, A22, etc. AM2 plus etc. Then first column last element Xn variable is a common, then take the outside, then write the coefficient value in the inside of the matrix A1n, A2n, etc. AMn. A linear combination of the matrix is a column vectors of matrix. Thank you.